Hello guys, let's see the properties of AP. So I mentioned some properties here as if Tn is equal to An plus B, then the series so formed is an AP. And similarly, if I have Sn given in this form, is kind of a quadratic form. So we can say that even though the series, whatever the series will be formed with this, that will be an AP. And the next third property we have, if the each term of a given AP is increased or decreased or multiplied or divided by some non-zero constant number, the resulting series thus obtained will also be an AP. Okay, and the fourth one is if an AP, the sum of the terms equidistant from the beginning and the end is constant. Okay, and equal to the sum. Okay, if it is constant and equal to the sum of the first and the last term. Okay, any term of an AP except the first term is equal to the half of the sum of the terms equidistant from the term. So I have given that an is equal to half of an minus k plus an plus k. Okay, let's discuss this property one by one with examples. Okay, so this is first property. I said if Tn is given like this, you can see there, if Tn is given as in this form, so you just put the n value, as 1, so it will be T1 and it will be a plus b. Okay, put t is equal to 2, means n is equal to 2, so t will be 2 and 2a plus b. Then n is equal to 3, t3, 3a plus b, and so on. Now just take the common difference of these. Are we getting a same common difference? So t2 d is common difference, which is nothing but t2 minus t1, so which is nothing but 2a plus b minus of a minus of b. So b cancelled out, what we got as a. Okay, so the d which I got as nothing but my a. You can check with the next two consecutive terms also. So d t3 minus t2, which is nothing but 3a plus b minus of 2a minus b. So b cancelled out, what we got this as nothing but again a. So yes, common difference is a. So in this kind of series where my Tn is an plus b, the series formed by putting n values will be nothing but an AP only, and the common difference is nothing but a. Okay, the next one is Sn. Sn is given in form of some quadratic. Okay, as you can see here, an square plus bn plus c. So in that case also, if I'm going to put n values from 1 to 3, so let's see what will be the result. So n is equal to 1, so s1 is nothing but a plus b plus c. Okay, now n is equal to 2, so s2 will be nothing but 4a plus 2b plus c. This is what my Sn. Okay, so I'm getting s1, s2. We don't have to put other values. We know that Sn minus of Sn minus 1 will be nothing but an. So you can do that part also. So by this is one thing. Okay, by this you get to know that, okay, I'll subtract this one, s2 minus s1. So what I'm going to get as 4a plus 2b plus c minus a minus b and minus c. Minus c cancelled out, and what we are getting as 3a plus b. So this is nothing but s2 minus s1. Okay, similarly you can do s3 minus s1 directly. You can get, there are two ways to get the an here, because the most important part is we have to get the an. So an we can get by two ways. Either we can put n3 value here, so n3 will be nothing but s3, which is nothing but 9a plus 3b plus c. So by that also, if I'm going to do s3 minus s2, so let's see what I'm going to get. So 5a plus b. Okay, so what I'm what I got as 3a plus b, 5a plus b, then definitely next one if I'm going to put will be 7a plus b. So if you can see that even though the common difference which we are getting S1 S2, the difference of S2 minus S1 S3 minus H1, we are getting as 3a plus b, 5a plus b, and subtract, if I'm going to subtract these two, the difference I'm going to get is nothing but 2a only. But I'm not saying that go this way. Okay, what is this? Why I'm doing this part is to find the an. So an is always, we know that, nothing but Sn minus of Sn minus 1. That's the most important point of an. Okay, so this is my Sn. Okay, and if I write Sn minus 1, which will be nothing but a n minus 1 whole square plus of b n minus 1 plus of c. So while if you are going to subtract these two, Sn and Sn minus 1, you are definitely going to get an, and that an, whatever the n value you will substitute, you are going to get the same thing which I am finding here, this thing. So an, by that an you can say easily directly that my series will be an AP, and by this thing also we can say that my series will be an AP only. Okay, there are two ways, you can choose anyone. So you can find Sn an from this by subtracting this formula, and you can find out the value, or else by this only you can say that this is nothing but my an AP. Okay, so next one is, if each term of an AP is increased, decreased, or multiplied or divided by some non-zero constant number. Okay, let us suppose I have AP 3, 5, 7, 9 and so on. Okay, so if I'll just multiply 2 here, or divide by 2 here, or add 2 here, because they said increase, decrease, whatever I'll do, the resulting series will be an AP only. If I'll add 2 here, 3 plus 2, 5 plus 2, 7 plus 2, 9 plus 2 and so on. So you can see that I'm getting nothing but as 5, 7, 9 and 11. So even though I'm getting an AP only. Okay, so first I did addition. Okay, adding plus 2. If I'll do subtraction, even though I'm gonna get this as same only, because common difference I'm going to get same. You can see the 5 minus 2, 7 minus 5 is nothing but common difference is 2. 9 minus 7 is common difference is 2. 11 minus 9 is common difference is 2. If you do subtraction in the same series, if you do subtraction or multiplication, you can do anyone. Okay, I'll take multiplication now. Multiply by 2. Okay, so 6, 10, 14, 18 and so on. Now take the common difference. 10 minus 6, 4. 14 minus 10, 4. 18 minus 14, 4. Again, common difference is same. It means my resulting series 6, 10, 14, 18 is an AP. So whatever you do with a constant number, that resulting series will be an AP only. Let's see the next property. If an AP, the sum of the terms equidistance. In an AP, the sum of the terms equidistance from the beginning and the end is constant and equal to the sum of the first and the last term. Okay, let's see the example for this. If I have a AP 3, 5, 7, 9, 11, 13, 15 and 17. Let's take the only limited terms I'm taking. 8 terms I've taken. They said the sum of terms equidistance. Sum of the terms equidistance from the beginning and end. It means if I'll say let's talk about the 9, it is basically at the 4th position, and again 11 is also the 4th position from the back. Sum of the terms equidistance. So sum of these terms, nothing but 9 plus 11 is 20. Okay, is constant. Yes, it is constant, and this is equal to nothing but sum of the first and last term. So sum of the first and last term, if I'll talk about, yes, that is also equal to 20 only. Why? Because 17 plus 3, which is nothing but 20. Hope you understand this part. Again repeating this part. 9, the terms equidistance from the beginning and end. There can be anyone. If you want to choose, we have to take the equal distance. If you will take 7, let's suppose I'm talking about the 7. Okay, so 7 is on the 3rd position from the beginning, and 13 is also on the 3rd position from the beginning. So the sum of 7 and 13 is nothing but, you can say that, 20. And again, this will be equal to nothing but the sum of the first and last term. You can, the first is 3 and last is 17. 17 plus 3 is nothing but 20 again. So hope you understood this point. Okay, next property. Next property says that any term of an AP, okay, is equal to half of the sum of terms equidistant from the term. Okay, same like previously we have done example. I will take one more example here. 3, 5, 7, 9, 11, 13, 15. Okay, sum of the term, any term is equal to half of the sum of the terms equidistant from the term. If I'm taking, let us suppose I'm choosing 9. Okay, so choose any terms which is equidistant. Like from 9, this 3 is on the third position. From 9, I'm saying from 9, and 15 is again on the third position from 9. So sum of these terms will be nothing but 15 plus 3 is 18. They said the any term of an AP is equal to the half of the sum of the terms equidistant from the term. So equidistant terms are 3 and 15. So half of this will be nothing but 9. So yes, this is nothing but my 9. Hope this thing is clear. Anytime you can choose equidistance. If I'll choose 13 and 5, that will gonna give you 18 only, and divide by 2, half of that term will be 9. Okay, so sum of the term, any term, you choose any term, even though 100 terms are there, choose any term, always this will be the same thing. Okay.